Hello everyone and welcome back. So today we will discover and learn about Databricks. However, in my previous videos, if you saw in same channels, uh, you will find snowflakes about that. So first of all, I will compare what is difference between Databricks and Snowflake. Why we are learning Databricks, what is the advantage of Databricks over Snowflake. However, Snowflake is also a comprehensive data analytics tool, but there may be some distinctions or there's maybe some benefits if we use Databricks. So let's compare this benefit. So if we saw Databricks and compare Snowflake versus Databricks, so the primary purpose of Snowflake is that data Snowflake is used for data browsing and analytics platform. However, Databricks is used for unified data platform for data engineering, data science, and machine learning. So I would say they are both in this nature, similar both in nature, but on a data types there is a difference. Snowflake support structured data, but Databricks support structured and semi-structured data. This is one of the big difference. I would say that Databricks is working on the layout of data lake and Snowflake is work as data warehouse. Okay, so this could be a main difference. And query language, in Snowflake we have SQL based analytics. However, we can use Python and R as well, but in Databricks we can use SQL, Python, Scala, more focus on data processing, analytics, and Apache Sparks. Strong data sharing capabilities, collaborate feature to share code inside among teams, comprehensive security, and in Snowflake we have a comprehensive security and governance feature. However, here Databricks is some sort of lacking, provides security and governance feature, but it's primarily focused on data processing and analytics. Then scaling is similar way because both are SaaS structure, software as a service structure, so we don't need any installation, just we need to plug in the cluster and ready to go. And use case is ideal for structured data analytics, business BI reporting, etc. And Databricks is well suited for data engineering, data science, machine learning, and both structured and semi-structured data. So this is a main difference. So let's dig into our Databricks side. So if you are newer and you did not create or sign up on a Databricks, so Databricks is actually provide a community based Databricks community which is freeware. However, it has some limitations or not fully function, but for your learning purpose it will serve all your major purpose. So if you are new, you can sign up this, enter your name and last name, email, and like that, and country name, and then you can continue. So I already created an account, so I am going to directly on login page. So this is our login page, community.cloud.databricks.com. so it's a community version, sign in database community version. If you have already signed in, then you just need to enter your email and password and then sign in the Databricks. So I enter my credentials and let click on sign in. So once you successfully sign in, you will get this type of interface. It's very much similar to Snowflake, but it has some other things, like we have a compute here. Compute mean we need to first spin our cluster here. We can create multiple cluster, and then we have a data. Under data we have a database and maybe structured data, and for semi-structured data we can use DBFS. And then on workspace we can actually create folders, multiple folders, even we can create notepad, table, and cluster. So there is two way, either we can go to compute or either we can create cluster here. So let me go in compute. So I have one cluster is already developed or created, so I am creating another one for you. Okay, so after successfully login in our community edition, Databricks or community edition, you can see notepad. We have a data import utilities, we have AutoML, quick start tutorial, transform data. So first thing is that we need to start a cluster. If we haven't defined a cluster, we can start a cluster. So we have an option, we can define and create a notebook here, which is, we can write a Python code, SQL, R and Scala code here. We can create a table and we can create a cluster. So another option is that we can go in compute and see how many clusters are working and which cluster is terminated stop. So there is no compute cluster here right now. So what I need to do, I will going to create a compute cluster here. So I am going to name it like C1 cluster 1, maybe it could be any name. So let's click on create. So what is going to be, it's taking a time. While it's taking a time, let's review something that I am going to use Apache Spark, this version Scala 2.12 version. So it has option, I just quickly created this cluster, so it has option we can use 3.3 3.5 version up to Spark, and by default it in a freeware it's allow 15.3 GB memory. So here you can see community edition, and the one thing which is actually most important limitation about it, that it will automatically terminate after an idle period of 1 or 2 hours. So this is one of the limitations. So if you, for example, if you have a stop working and you have a midnight or night and then you came back next day morning, so you may find that your cluster will no longer be available. And finally we have a zone, US VETS 2B. It can be any Indian zone or UK zone, Singapore zone, depending on the your uh, availability of the zone. And we have a Spark. Okay, so Spark configuration, we have JDBC, ODBC driver if we want to connect with our SQL server or from Python code, so we can use this string. Okay, and it has this version, and cluster is created and running. But before going to that, I am going to quickly show you about some quickly one or two things that we don't have any notepad associated, because we have just created our cluster. We don't have any libraries. Actually libraries, I will go to click install. So in libraries we can install our libraries from external source or PyPy or Maven. Like for example, I'm going to use Maven and I want to install packages like we do in pip install with Python, like Spark CSV, so Spark MongoDB, let's say. So we have different type of thing and we can select here, and let me say that I'm going to install it. So it will take some maybe time, not taking too much time, but it's just like a pip install. You can wait for it, or let's wait for it. So our Maven package is installed and we have event log if we want to see what is going on with our C1 cluster. Spark UI, we don't have anything, but it's a job portal type, Spark portal type things. Driver logs, so standard output, log4j output, and apps, web terminal, like this. So just come back to our main thing, that compute. Now we can see that we have a C1 cluster, it's running, it's 50 GB and assign a 2 core. And here if you want to terminate, you can just click it, or you can use restart, clone and delete as well. So we are good to go, and let's create our data. But for data we have if we want to use RDBMS, RDBMS or relation data or structured data, we can use database table, or if we have unstructured data like CSV file, or you can say not CSV file, JSON file, so we can use DBFS. So let me first create a table using my local data uh, local files. So here's option, we have a upload file, we can fetch data from S3 bucket, DBFS and other data source. Like in other data source we can use MongoDB, Kafka, JDBC, but for the sake of this demonstration I am going to use a CSV file or text file. So here I have option drag file to upload or click to browse. So let me go in my local system, and here I have a semi-structured file and a structured file. So let me take iris. So iris.csv, create table with UI, and I need to tell about the cluster. I am attaching cluster C1, and now I am clicking preview table. So it's going to load my data or previewing my data of iris.csv file into table view. However, I have a option first row in header. Yes, I can select this because my first row contains a header, not a actual data value. So let it be processed. So my data is uploaded in a table preview. You can see I can change the data type here, for example int, big int, like I can use double float, and it's up to me actually that what type of things I want to use, and then string. Okay, so after that, once I am okay with the schema and review the file, that file is okay, and then I can go to create table. I just need to create table. So table is created, and you can preview the schema, right? And here is your sample data. So this is a very cool feature, and let me go in a, you can see iris csv file here. So under default folder we have iris csv file. However, you can change your default database into meaningful name, but for the sake of the demonstration it will put iris.csv. If you click it, then you will see again schema and then sample data, right? So we are good to go here. Now next step, we need to create or upload data with our file system. Okay, so let me go. We don't have any table here. However, we can use same JSON file. Okay, so iris.json file is available, and keep in mind that it is a semi-structured data file, right? So we have a structured file iris.csv in database table, and in dbfs we have a semi-structured file. So we work and upload both files in our, you can say, data lake, and data lake is associated with C1 cluster, right? Next step could be our to create our workspace. We select workspace, and we can either create a new folder here. Okay, so let's create a new folder. For example, my folder name is machine learning ML. So it's created a new folder ML here, and under ML we may have created another folder, libraries, notebook, or ML flow experience. However, we can clone, rename this folder in a later stage. So all the things we can do, even we can export our folders data to HTML source file like this and copy link address. So after creating a folder, I am going to create our notebook, right? So here we are in a notebook, and let's say Python sample. My notebook is Python sample, and here I have four options. Either I can write Python code, I can use SQL, I can use Scala, I can use R language. Whatever the language you are comfortable, you can work on this. Let's say I am going to use SQL. Okay, so now it's switched to SQL. Before that it was Python, now it's switched to SQL. If we select SQL, so we can write our SQL queries here, like select star from, and we know that default is our database, and then under database we have irs csv table, and let me run this. Run cell, we have option run cell, mean run this cell, run all above, run all below. So we have currently one cell, so let me run this. So here you can view your data in a SQL. So this is a simple demonstration how we can create our uh, cluster. Once we create our cluster, actually cluster is here, you need to associate cluster is here, and you can have a multiple cluster, so you can switch the cluster from here, and if you run all that, mean it will run all the SQL commands under this button by clicking this button under this notebook you have created. If you want to delete this, you can just click delete, and if you want to add one more, then click insert. If you insert, so you can insert as many as command, so here you can write your SQL queries. So I hope you understand this point, and let me come back with the important thing that we need to write our Python code. For that I am going to delete all the and switch into Python code, and I am copying my Python code which is I already developed, so and paste in the notebook here. So now my objective is to actually fetch our data from database or as well as file system using Python code. So how we can do this? So let me rename this notebook name Python to fetch data. Okay, so we can use pyspark. I am in a Python environment. Okay, fine, and I am going to paste my code here, and let me get you overview that I am going to create a Spark session here. For that I am going to import necessary libraries which is actually already supported, so we don't need to be install it here. We don't need to pip install for this Spark session. Okay, so second line of code is saying that we need to assign our session name, like its name read from database Spark, and then here is this is a line actually spark.table default.irs.cv rs underscore cv, actually it's read our data from default.irs underscore cv file and finally we have a to show our data frame what we have. So let me run this code. It executing, and here you go. Similarly, if I want to use dbfs file store and dbfs, how we can fetch this file? For that, actually what I am going to do, I am creating a data flow. I am adding a line below and read data set using Spark file store. So what I need to do, I am going to use spark read.csv, assume that this is a csv file, assuming that, but it's not a csv file. Let me show the data.show, and you can shift enter to compile. Okay, so you will see a result, and second result set is here. And if you want to commit it out, let's say, and then again shift enter, so it will show you data output, right? Because we have a JSON file instead of CSV, so I am going to commit this code, control KC for commit, and I'm going to add this line of code. Instead of writing CSV, I'm going to use spark.json, spark read.json. So let me run all. So here we go, we have a JSON file format, and it's printed. Display all the record, actually display only 20-30 records, so for the sake of the speed performance. So I hope you understand this thing. And where is our code is safe? First thing, where is our notepad file is safe? So it's a very important thing. So I am going to see that my code is saved in fetch to data, but I want to move it or save it actually on my Spark machine language ML in this folder, and I'm going to select this. So here we go, we have a Python code and Python to fetch data, and this file is now moved in our this location. So this is our directory management, or you can say file management or code management, where you want to save. One more quick thing which is actually I would like to tell you about, that if you don't see dbfs folder here, maybe in some case you will not able to see dbfs folder here. So what you need to do, you need to go in admin setting, and under admin setting you need to go workspace setting, and workspace setting, scroll down, and here dbfs file browser. If it's disabled, you need to enable it. Let me show that if I am disable it, and now I am going here or refresh it. Let me refresh this page. Let me check. Yeah, you see the dbfs folder is now disappeared. So what you need to do, you need to go here again, enable it, and then refresh it. So this is quick actually troubleshooting, because maybe sometime you are not able to get dbfs folder here. So here we have a dbfs folder. Under dbfs folder we have a hive which is default, warehouse which is default. So we will work later in my videos on the advanced part of the Databricks. So let's grab this concept by watching multiple time of this video. So you have this is a basic tutorial. Actually I covered the basic concepts, not going in detail way. I am trying to explain you simple way that you have to be get familiarity with the database environment. So thank you very much for watching this video, and see you soon with the next uh, videos on Databricks.